Yeah, in this video we will see how to find duplicates in a string if any alphabets are repeating. So we have already seen the same thing in previous video. We have learned two methods. Now the third method, that is using bits. So in this video we will learn how we can perform the same thing using bits. This method is not just for a string, but it is useful for integer numbers also, but it is more favorable for a string. So let us see this method. So for learning this method, we should have some concepts with us. So let us revise those concepts. Then we will find the duplicate elements in a string. See, the concepts that we should know is bitwise operations. What bitwise operations we should know? Left shift and bits ORing, which is also called as merging, and bits ANDing, which is also called as masking. So we should know these things. Then we will see how to find duplicates. So let me explain you about all these things one by one. So here is a byte. See, for understanding bitwise operation, we should know how the data is stored in the memory in the form of bits. So for understanding that, I have taken just one byte. So it is sufficient to understand by using just one byte. Suppose I have a variable which is taking only one byte. Let us say character type variable. So I am calling that variable as h and it is taking one byte. So one byte is 8 bits. 8 bits makes a byte. So I have taken 8 bits and this is called as least significant bit and this is most significant bit. Means this is 0. Usually in an array we start indexing from 0, 1, 2, 3 onwards. That is we go from left to right. But this is indexed from 0 to 7 on this side. We started from right hand side. So this is least significant bit and this is most significant bit. Now how any number is stored in the form of binary, zeros and ones. So for this you should be knowing binary number system. I am not going to explain you binary number system. Now we will understand bitwise operations. So for that, let us assume this h is initially 0. Say h is 0. If I declare a variable of type character and say h assign 0, then 0 will be stored. So how 0 is stored? All these will be zeros. Yes, all these will be zeros. Then if I store 1, then this will be 1. So how it looks like in the memory? 0, 0, 0, 0, 1. If I read it from left hand side, because we usually read from left hand side. So this is 0, 0, 0, all zeros, then last 1. Then if I store 2 here, then binary form of 2 is 1, 0. So this is 0, 0, 0, 0, 1, 0. Yes. Then if I store 4, then the binary form of 4 is 1, 0, 0. So this will be 1, 0, 0. If it is 5, then the binary form is 1, 0, 1. So it will be 1, 0, 1. Let us make it back as 4 only. Now next I will skip 6 and 7. Let us take 8. If it is 8, then binary form of 8 is 1, 0, 0, 3 zeros. So this looks like this. So this means that this binary bits represent 1 and this represents 2, then this represents 4 and this is 8, double. It is getting doubled every time, right? 16, 32, this is 64 and this is 128. So yes, this is how the binary value of each digit, right? So if suppose we want to store 10, then 8 and 2, these two will be 1, 1, right? This becomes 10. Just we want 8, then this is 1 and all are zeros. Right? Suppose we want to store 20. This 16 will be 1. So nearest number is 16, right? 32 will be greater than 20. So nearest number is 16. Then what is remaining? 4. So this one. So these two will be 1. So it will become 20 in binary form, binary number system. Right? If only this bit is on means 16. So we have seen how binary form of a number is stored in the memory, right? Now next we will see what does it mean by shift operation. So I'll remove this and explain you. See, right now h is having 0, 0, 0, 1. So right now h is 1. Okay. Now let us see what does it mean by shift. H left shift 1 and the result in h only, right? So whatever the value of h is, see here is 1 bit, or whatever the bits are 1, whatever it may be, all bits will shift by one place on the left hand side if you mention 1. All bits. So we have all bits as 0, only that 1 is there. So it moved by 1 place. So this 1 comes here. Then this place will be vacant. No, this will be filled with 0. If the bits are shifting on this side, then you get some blank bits here. So that will be set as zeros, right? Now what is this number? It has become 2. Yes. Then let us put it back. This as 1 only and this as 0. Now if I left shift by 2 places, H left shift by 2 places. So this will be shifted by 2 places. 1, 2. So that 1 comes here. Then this is 0. So now how much it is? 4. So as I said, left shift and the result stored in H means this H will modify and it will become 4. So only this operation will not modify H, right? We have to store it. Now it means by shifting the number on the left hand side, we are able to increase it multiples of 2, and also the digit is shifting, right? Suppose here I say H left shift by 5. Right now it is 1 here, right? By 5 places. So 1, 2, 3, 4, 5. So it will come here. So what is the number now? See, these are all zeros. Only this is 1. So this is 32. Right? So we can shift the digits. So we can shift all the digits, but we are interested in only one digit, that is 1. So we are looking at through an example 1. So I have explained you shifting. Now I will explain you and ORing. So first let us see ANDing, then I'll explain you ORing. So for explaining AND, I have taken an example. I have taken two variables here, two variables, A is a 10 and B is a 6. So I have taken just 4 digits of those numbers because these rest of the digits on this side are zeros only. If I write all 8 bits also, they are all zeros. So I am showing only the useful bits, right? So these are last 4 bit and these are last 4 bits. So it is just like 1010 for A, and for B it is 110. So I have used this one also because that makes 4 bits from each side. Now what is AND? If I say A and B, then bits are ANDed. 0 and 0 means false and false, is false only. 1 and 1 means true and true, yes, true only. So 0 and 1 means false and true, is false. Then 1 and 0 means true and false, is false. So you may be knowing this if you have A, B and you are performing AND. So this is 1, 1 is 1 and 1, 0 is 0 and 0, 1 is also 0. 0 and 0 is also 0. So when you perform AND operation, then this is the result. So but we are performing not logical AND, we are performing bitwise AND, single ampersand. So the ANDing will be done upon the bits of numbers, bits in the memory. So what is the result we got? This is binary form of 2. So it means 10 and 6 is 2. 10 and 6 is 2. So this is AND operation. Next, I'll show you OR operation. Then we'll move ahead. Let us see OR operation. See, same number. I'll remove this. Now, instead of ANDing, we are performing OR operations on a bit. Then OR means what? 0 or 0, 0 only. 1 or 1, 1. 0 or 1 is also 1. 1 or 0 is also 1. Then, how much this is? This is 14 in the decimal number. Binary form it is 1110 and it is 14 in decimal number system. See, this is ORing. ORing means what? 1 or 1 is 1, 1 or 0 is also 1, and 0 or 1 is also 1, 0 or 0 is 0. So if any one of the bit is 1, then it is 1. So that's what we have performed here. And 10 or 6 is 14. So this is interesting, bitwise operations. Now let us understand what does it mean by merging and masking. This I have explained you and OR operations. Now merging and masking I will explain you. Now let us understand masking. Now for explaining masking I have taken two variables H. H is having all zeros except this one. So the value inside that is 16. So this is 1 byte long, right? So H is having value 16. Then there is one more variable A and it is having 0. Now what does it mean by masking? See, I want to know whether at this place, that is bit 2, 0, 1, 2, right? At this bit, is it 1 or 0? I want to find out that. Right? How to find out? Inside H, I want to know whether this bit is on or not. That is 0, 1, 2, second bit, or if I count 1, 2, 3, third bit. So let us call it as 2. I want to know whether that bit 2 is on or not. So how to know that? So I will take the help of A. So inside A, I will write down 1. So this is A assign 1. Then I want to check this one, right? So 1, 2, 3, 1, 2, 3, that is 2, least significant bit 2. So move this 1 2 times. So left shift A by 2 places. So this one will move here, then move here. So it will move here and it will become 0. Now we have A with 1 moved by 2 places. So what is the value in A now? It is 4. Value in A is 4. So remember I have shown you these, right? So this is 4, this is 16. It is 16 here and it is 4 here. Now, how to know whether this bit is on or not in this one? Perform ANDing. If you perform ANDing, then 0, 0 is 0, this is also 0, this is also 0, this is also 0, this is also 0. All are zeros only. So if you got 0 means bit is off. If you got non-zero value means bit is on. So by performing AND between A and H, I can know whether that bit is on or not. So knowing a particular bit inside a memory, whether it is on and off, is called as masking. Now let us do it for this bit. See, already this bit is on. Let us check for this one. So first of all, set A as 1. Okay, A as 1. So this is at which place? 4th place. So move this by 4 places. So it will move 1 by 4 places. Left shift. 1, 2, 3, 4. So it will move here. 1 will move here. Actually all zeros also will move here, right? It's not crossing over this one. See, it is just like this. When we are shifting means this 0 comes here, this 0 comes here, this 0 comes here, this 0 comes here, and so on. And 1 will also move. Like that it will happen 4 times. Alright. So this 0 is here now. And these are all new zeros that came there. So it is left shifted and it is here. Now if I perform A and H, I'll get true. Yes, this is true. So it means that bit is on. That's perfect. Now next thing, I'll show what does it mean by merging. Right. See, already this bit is on in this one, right? And I want to set this bit as on. Inside H, I want to set this bit as on. So for setting that bit as on, I will take help of A as 1. Yes. Left shift A by 2 places. So A will move here. A will come here. This will become, that 1 will come here and that remains 0. Then perform OR and store the result in H only. So 0 or 0, 0, 0 or 0, 0, 0 or 1 is 1. Right? And this is 0. This 1 or 0 is 1. So this is 0. So the result of this one will be 0, 0, 0. 1 0 1 0 0, right? So this will be the result and that is stored in H. So this becomes 1. So already some bits were on and we have set other bit as on. That is called as merging. Setting the bit on in memory is called as merging. Checking whether it is on and off is called as masking. So these two operations we have seen, bitwise operations, left shift, masking and merging. All these things we will use now for finding duplicates in a string, right? So finding duplicate, we will see it in the next video, that is continuation video. So otherwise it will be a very big video. So let us break it. So watch the next video for finding duplicates using bitwise operations. This is the continuation of previous video. If you have not seen previous video, go back to previous video. There I have explained how we can use bitwise operations to manipulate the bits of a byte in the memory. We have seen masking and merging. Now we will use that masking and merging to find out are there any duplicates in a string. So already we have an example string where I is repeating and N is repeating. So just we can find out are there any duplicates or not, right? We cannot count how many times that element or a character is repeating by using bits. So just we will find out whether the bits are already there or not there. So let us see what we need for this procedure. See, similar to hashing, we need some space. So in hashing, we have taken an array of 26 size. So now we need 26 bits, but we cannot get 26 bits. We get in terms of bytes. So 8 bits makes a byte. So we can get 32 bit, that is larger than this one, right? Otherwise we get 16 bit, that is 2 byte, that will be less than this one. So together 32 bits we can take. So what is 32 bit? So that is 4 bytes. So 4 byte means what? Either it can be an integer or it can be a long integer. So long integer takes 4 bytes. See, we have been assuming that integer takes 2 bytes, right? I was assuming this one. So if integer take 2 bytes, long take 4 byte. But in some compilers of C, C++, integer itself takes 4 bytes. So just an integer is sufficient. You don't have to take long for it. So 32 bits or 4 bytes you can get just using an integer. So I am assuming, as per my assumptions, I am taking long int, right? So that is of 4 bytes. Now what to do with that 4 bytes? So first of all, I will draw 4 bytes, then we will discuss. Here I have 4 bytes, right? So this is the least significant byte and this is least significant bit, 0 to 7. Then next byte is 8 to 15 and so on. So this is just like a hash table. In the hash table, we have taken a hash table of size 26 in the previous video, right? So here we are having total 32, 0 to 31. So actually we need up to 0 to 25, right? Up to here it is useful. Few bits are extra, that is not an issue. Then all these bits assume that they are set to 0. Yes, they are set to 0. So for this, I will take one variable there. I will take one variable long int h and this is initialized with a 0. Yes, so all will be zeros. Now, this I will use it for finding duplicate. How? I will scan through a string. For every alphabet, I will set the bit on here. But the ASCII code of this is 102, right? So actually from 102, we will subtract 97 and we get 5. So we'll set this 5th bit on, right? You remember in the hashing, we have done the same thing. At the 5th index, we were incrementing it. But now we will set this 5th bit on. And for this I, it is 105. So 105 minus 97 gives 8. So we'll set this 8th bit on, right? So next time when we come on this I, then again it is 8. So we will go and check 8th bit. It's already on. So I is duplicated. So before setting it on, we will check whether it's already on or not, right? How do you check whether that bit is already on or not? By performing masking, ANDing. Yes, we know that that is already on. If it is already on, then we say it's duplicate. Now A of I is F, letter is F. It is 102, right? So as it is 102, I will subtract 97. So A of I minus 97. So for every alphabet I will do it. So for this I will get 5, for this I will get 8. So now what to do with this 5? I have to check whether this 5th bit is on or off, whether this 5th bit is on or off, right? 0, 1, 2, 3, 4, 5. If you count it is 6th bit, but index is 5. So that bit is on or not. So how to know that? By performing masking, I can know that. So I should have one more variable where this bit is set on and I should perform masking. So for that, I will take one more variable that is set to 0. And here, before this, I will set x as 1, right? I will set that x as 1. Then that 1, I have to make this x shifted for 5 places so that it comes here. So this difference, whatever the difference is, I should shift this x. So x left shift for these many times and assign it to x. So I'll write x here, x assign 1. Now this is little tricky statement. Check this. X is 1, right? See, this is another one. I am not drawing boxes here, right? Already I have boxes for variable h. So similarly, assume that these are the boxes for variable x, 0, 1, 2, 3, 4, 5, 6, 7, right? These are the boxes. So I'm showing only for the one variable, right? Otherwise I have to draw all of them. This is variable x, right? Which is 0. Now first set it as 1. Then left shift this x by these many times. So how much it is? Right now f is 102. So 102 minus 97 is 5. So it will shift this value 1 by 5 places. 1, 2, 3, 4, 5. So 1 comes here. And all these are zeros. All these are zeros, right? All are zeros. So I got 1 here. Now check inside H, is that bit is on or not. If it is already on, means it's a duplicate letter, means already it's there. If it is off, means set it on. So I will check here. How to check whether this is on or not? By masking. So X and H. If X and H, the result by ANDing is greater than 0, means we got some non-zero value, right? If that is off, means we get 0. If that is on, means we get non-zero value. If it is so, then print that so and so letter is duplicate. So printf percentile C is duplicate. Percentile C is duplicate. So who is duplicate here? That is A of I. For F it is not duplicate. For I and N you will get duplicate. So A of I, whatever I is. Right? It's already there. If it is not there, means if it is not 1, then set it as 1. We got that digit. We got that alphabet. So set it as 1. How to set it? By performing merging. So X or H. Store the result in H only. So this will be set as 1. So that's all. This is the close of loop. So wherever there is a duplicate, it will display that alphabet. If any duplicate alphabet is there, it will display it. We have used shifting for preparing a number so that we can perform masking and merging, right? So for this bit, for F, bit comes here, and for I, 8th bit will be on, right? This will be on. So we check for this one, is it present or not? So in this way, the bits for 5, this will be set on, and for 8 it will be set on, right? And for this one, 103, this is 103. This 6th bit is also set on. So this is 102, and this is 103, and this is 100. So this is also 1 for 100. Then 105 is already over. Then 110, 5, 6, 7, 8, 9, 10. So this is also on. So rest of them all will be zeros, and these bits will be set on. And when again it finds that I is already there, so I is 105, so 105, it is already there, so this is duplicated. Then for N, 110, first time this will be set on, second time it will check here, this is already there, so this is duplicate, right? So for checking this one, we need 1 here in X. So how we are getting that 1? Initially we are setting this as 1 by this and shifting it that many times, right? Shifting it that many times. How much times? See, 110 minus 97, so this is 13. So it should be moved by 13 times from here. So I will show here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it will come here. Then we'll perform masking to know whether it's already on. If not, we will set it by merging. So this is how we can use bitwise operation to know the duplicates inside a string, but we cannot count, just we can know whether there is a duplicate or not. And we can know what is that letter that is duplicated. So that's all. This is a simple program, so you can write down and check it, right? And if you face any difficulty, you can pose a question, right? If you want me to give you the program, I will give the program. That's all.